may I have everybody's attention? I would request everyone to take their seats back, and then we are going to start with our next talk. So our next talk is going to be about a system called as ADA. So we are going to discuss the making of this ADA system, which handles data in petabyte scale. We will get to know about the strategies, decisions, and some real-world challenges that we have faced while making of this ADA system. And Anay and Aman are going to present the talk. I would request them to come on the stage. Yes. So a brief introduction of Anay and Aman. Anay with 19 years of experience, though he doesn't look like, but with 19 years of experience, he has expertise in developing large-scale projects. He has experience of working in data platforms, as well as he has worked on data science applications. So if you want to have like good data insights and build like a robust data pipelines, then you should talk to Anay. And Aman Sheikh over here has his expertise in Spark, Python, and he has worked on developing interactive system. So Anay and Aman are going to discuss the making of ADA system and how we should handle data when the data is in petabyte scale. So over to you guys, and all the best.
Thank you. Yes. Awesome. So I'm hoping you all have had a great day so far, and I want to start off with a little bit of what ADA is, right? So we've built this product over the last 5 years. We want to talk about what journey we've had and what are the two learnings that really mattered for us. I think this also starts off with one of the things that we don't tend to notice, which is the billboards on the street. They are like advertisement. So it's not like that you're going to consciously think about, hey, what do I do about this? So I want to set some context for it first, right? So we'll do a bit of a brainstorming exercise, right? I want you to imagine that, let's say you are a member in an advertising firm, and what your job is to figure out what are the best places in your city where you would want to place your ad, right? On the billboard. So the billboards are the big frames that you would see on the street with a number saying call me and we'll let you buy it, sort of thing. Take a minute. If you get to a few, you can probably raise your hand and we'll probably talk about it. Just imagine a premium car company, right? And think about in the city, because there are tons of places, the ads everywhere. Do you have any thoughts on where this might belong? Feel free to raise your hand and talk about it.
Imagine I'm a builder, so मैं तो हिंजौड़ी में ही खड़ा करूँगा मेरा billboard site. So
absolutely. So proximity sort
proximity
of basis,
is important.
Right? Yeah,
I probably in some places I have to know the footfall. So if I know that there's a mall where there's a high footfall, then I would probably place my F&B kind of ads there.
Yeah.
Or high-end brands and luxury brands there.
You're almost trying to put the mindset in there and trying to think.
If I have to sell a Porsche, I will put it in Kalyani Nagar.
Yep. So, great ideas.
Places of traffic where you will have people waiting over.
So you get a lot more eyeballs who are looking at that ad.
Yes.
So
and
great
especially
fit
the placement.
Perfect.
In the line of sight.
Anyone else?
Times Square, New York.
So you also need to imagine a budget, by the way. So, so imagine you have 10 lakhs, right? Like let's do this in India. And you could pick now, right? You're right, Times Square, so maybe our budget is in dollars now, and that's different. But even then, I think you'll have to make choices about Times Square, maybe you'll get one, right? Versus somewhere else, it's probably a lot cheaper. Cool. So I think you've touched upon some of the things. I'll add on a few more. Right, the billboard, there are basic things out there as well, right? How big is it? If you've gone through Mumbai-Pune Expressway, you remember like a massive Jeep poster, which everyone can see because there's nothing else to do there, right? So similarly, if it's digital, right? And digital has a lasting impact. You see it at night, which you can't see with the paper-based ones. The other is the cost, which I think we briefly touched upon. If it's too expensive, you might actually prefer to do some of the other ones instead. Or you might also consider, hey, should I do digital? Because I can run a Facebook campaign quite easily as well, right? The brand, if it's a premium car company, I think one choice is, would you put it at a railway station? Right? It's an interesting mix. Maybe it works because you'll get tons of people looking at it. Are they interested in your premium car? Maybe not. Right? So you have to think about that dimension as well. Availability, like let's say, like you said, Times Square, right? Sounds great, but I'm pretty sure it's sold out for the next 6 months, right? And if your car is getting launched in 2 months, you need to think about, is this really available right now? The other bit, which is a bit of a sidetrack, is regulations. This depends upon industries that you're dealing with. So, for example, smoking-centric ads, you don't want that next to schools or whatever, right? I mean, obvious ones like that you would want to skip. Lastly, I think this is an important point, which is the target audience, right? You could get maximum eyeballs wherever, but those might not be the eyeballs that you care about, right? It needs to match the audience that I'm actually looking at, right? Like, so if it's a premium car, I would want people who are interested in cars, and that's a perfect match as compared to millions of people who don't really want your car, right? So that's basically what we were tasked to do, right? We were working with a UK-based out-of-home specialist. Out-of-home is that industry where you're figuring out what billboards are the best. They had an end-to-end planning system, right? Effectively, that meant that you could, it meant that you could go and make purchase decisions out there. You don't have to go pick up the call, talk to someone. You can do nice dissection of data, figure out, okay, I want to run this in central London. That's the sort of audience I want to run with. So that lets you do that quite easily. UK, by the way, also has a lot of media owners. Media owners are the people who own those billboards. So effectively, you don't want to call 50 people, right? You would want to have all of that in your system. They also did have an existing data platform, but it did not scale quite well, right? So if you imagine for UK, if you want to run a national campaign, it would take probably 2 weeks because it can't handle all of that data. So you have to dissect the entire country into smaller chunks, run each one of them individually, and then say, oh, now I have enough to be able to run this nationwide. Because you don't want all your ads to run in central London, right? I mean, there might be people in other places who are also interested. So you want enough spread of your inventory in your ad campaign so that maybe everyone knows about it, right? So I think the off-the-shelf product also came with a fat bill, which was $700K per year, which effectively meant that if you wanted to go off this platform, we had to match the subscription frequency, right? Like effectively, you either take 6 months, roll it out, or you have another year before you can actually go out, and you're spending another $700K. This was a fairly tight project, so we had 6 months to actually go to the first go live. Had to build 5 different data science models under the hood to actually make it work the way we wanted to. And all this with a 10-person team, right? Which is a fairly small team building a data platform which doesn't exist while they have an existing product which is quite different. So we're going to talk about this in terms of ages. For the gamers in the house, I think this is mostly of, I think, strategy games. If you're interested in games, happy to have that conversation as well a bit more later. But our first target was, hey, can we get to a minimum viable product which will let me run this system, right? Just like how I used to do this before, but hopefully better. So that hopefully goes back to how do you go about building an audience, right? We talked about it in the first one where we're talking about a premium car. If I have to do that via a system, what is it that I would actually need to be able to run something like that? Because unlike online ads, where you have pixel tracking and everything is really available, there's nothing available in the out-of-home. You're just passing by in a car, you might be in the wrong lane, you might be busy with your mobile phone, I don't know, right? There are 5 ways you might not be looking at something that's sitting in front of you. So I think for such things, you want to start off with a question. So if you look at the image on the, I guess the right for you, you'll see, which is like the night map of London, or UK rather, right? And it's quite easy to see hotspots, right? You see central London, you'll see Manchester, you'll see a bunch of them. Now imagine if you had a trail of anonymized device points, which give you a data set around how people move around in general, right? And you should probably imagine this in the context of the problem statement that we are talking about. You can then overlay that information with tons of other information to try to make a bunch of different inferences, right? So you could probably identify, this is not just nighttime anymore. So effectively you could have the entire day, and then you can find other data points on it. So what are the popular malls that people visit to, right? What are shopping centers that people might be visiting to? You don't know the people per se, but because it's anonymized. But on a broader spectrum, you want to get a sense of how is the industry moving around, right? And if you overlay that, you could probably answer that question, hey, how can I find the right audience who might be interested in my car? So it might be people who are visiting my showroom, for all you know, right? So I'm going to go on a bit of a tangent and talk about models, because we had to build 5, right? And if you've heard about this enough number of times, 85% of any data science model that you build will, in all likelihood, is not going to go to production, right? Tons of issues that make it very limiting. So you're going to start off with maybe what's the concept, right? What is it that you're trying to solve? So in this case, maybe it is, hey, if I had to identify visits to different malls, can I actually do that, right? The next step is, okay, what does it take to actually solve something like this, right? You might have different ideas as a data scientist thinking about, hey, can I overlay this? Do I have enough information? Those sort of bits, right? You might still have that data that we talked about, but it might not be the right quality. What if all the data is only about central London? You're going to say that all the other places are just dead, there is nothing else out there, right? So you want a spread of it. You also want good enough data in different forms. And once you sort of have that sorted out on a hypothetical basis that, yeah, I looked at the sample data, it looks great out there, maybe it's time to go ahead with this approach, right? And that's when you start thinking, okay, I need to start building the data pipelines that can process billions of data points and actually run this at scale, because it's no longer on my machine anymore, right? So you're running this at production grade. And eventually you're going to hit a bunch of different issues there, which is, oh, what I tested this on 3 months back is no longer the reality. The data that is flowing through is completely off as compared to what I thought I'm going to get. And after a few tries, you'll eventually have that model being rolled out, because now it works, you have to tune it, and effectively it serves your use case. This entire spectrum has challenges at every stage, right? Any of these can say that, oh, a model is not going to work for me anymore, because that model required the data to be like this, and I don't have that data in that granularity. So effectively, I think it becomes fairly important, how do you address a challenge like this? Because we only have 6 months. We want to build 5 of these, and the likelihood of failure means we get 1 more year free, not really free, but with another 700K down the drain. So it's really important for us to actually identify how do we iterate through this and fail fast so that you can actually refine and fix the issues that you see. Now, in terms of the underlying architecture, right, and we've kept this at a fairly abstract level. We won't be talking about the data science models because that's a bit of the secret sauce. But I think the green bits that you see out there, right, are bits that we'll start with, right? So these are your data sets that you're getting from third parties. So you might have anonymized device location data. You might have geolocation boundaries, which is UK at different levels of granularity, right? So whether it's a postcode or TV region or whatever else, right? And the inventory, which is around 600K. So all over UK, you're going to have massive inventory which is floating around, of different types, of course. The digital inventory, by the way, I forgot to mention this bit, you can actually book that down to a very low granularity, right? Like it's not like you have to book for the entire day. You could almost go for the minute and say that I want to book that. Now, if you look at that data and the places of interest, which is things like malls, right, that's around 1.5 million places as well. You want to have all of this data combined together in different ways with different data science models, which can actually tell you, do I have the necessary insights, right? So for example, we talked about visits, which would be one such dimension where I would have a model which figures out, hey, is this actually a visit? Does it qualify? Maybe it does, so I'll add it to that data set. We made some interesting choices here, by the way. So this was running with Spark, and this was back in 2019, so Spark 2.4 and Airflow 1, right? So V1. So people who have worked on Airflow, is there anyone in the house? But I see some heads nodding. You might know some of the challenges that you would hit with Airflow 1, especially around testing. We'll touch some of those bits as well. This data was flowing through once a week for us, right? And effectively, those choices worked fairly well for us, right? I mean, you have batch data coming in, you want to process that. No one's running a campaign for the current week because you want to run that a little bit out in the future. Otherwise, you're not going to get that inventory either ways. And the other bit being, we also had to make some choices around the infrastructure, right? So effectively, we would run this via spot instances on EMR. And the choice of spot instances was primarily driven from cost. You're now building a product which you don't really know whether it's going to work. So you want to have a rock solid foundation which is driven off unit economics so that you have a sense of, is this really going to work at the scale that we're thinking of? Now the bit that I think people will notice out here is towards the right, there is no user interface, right? What you have is Athena and a Jupyter notebook, which is not what users use, right? This was, I think, us trying to do ruthless prioritization, right? Effectively, if you have your team building a UI, your team is signing up for an opportunity cost there. You have, if you look at what your users really care, they care about the rightmost bit, and what we have is the data on the leftmost side with tons of models to build in a tight timeline. So you really want to figure out what is my critical path, get that sorted first before you think about any of the peripherals out there, right? So which is where I think this was even what the clients were fully onboarded with, that, hey, we'll start with Postman, you focus on the critical part, and we'll change this when we need to, because there are 2-3 people who will actually create these audiences for us, right? Cool. So I think we went about building some of these things. I think the challenges now are ones that start surfacing, right? So effectively, if you have, let's say, while the data provider will commit to, I'll give you this data every day or every week, right? And feel free to process it. They also are going to have issues on their end, right? Which means that data is not really going to come to your system. You might have data which is no longer there for a particular day or a particular week, which means that all your downstream pipelines are going to just fail one after another, right? We don't have a separate team which is responsible for managing your infrastructure or for managing the alerts that come through. This is effectively your dev team of 10 trying to fix all the issues that comes in, which is great feedback because now we know what do you really need to fix. It's not someone else's problem, right? So if something fails here, and the obvious one being, I don't have the data for that week, then you would want to stop the pipeline there rather than fail everything downstream and then realize that, oh, I need to actually start fixing this again. Right? So those are some of the choices that we had to make in the early MVP phase, right? Effectively, while parallelly trying to build different data science models, different Airflow DAGs and pipelines. DAGs are basically, the sequence that you see is almost a DAG, right? Where you have a job upstream, a downstream, and effectively that's a graph of things that run through. Cool, so our first go live sort of went there fairly well, right? With the set of constraints that we signed up for. But it came down to certain things, right? Like we said, one is ruthless prioritization. You don't want to work on anything that is absolutely useless. And by useless, I don't mean in terms of it's not important, it's important but not right now, right? So it's important to make it work, then you sort of fine tune it beyond that. The critical, identifying the critical path was the other bit. If you have that sorted, then you know what you really need to focus on, and you can parallelize across the team in terms of getting that done. The part that is equally important, especially with data products, is how do you ensure that quality is right? And you can't wait until 4 months down the project to realize that my data quality is bad, right? So you want to do this as soon as you can. So for the points of interest that we talked about, it might mean, can I look at a distribution of the top points of interest by their category and see whether it aligns with what kind of audiences I run? So if I'm running something for people who visit malls, it better be there with the malls that I care about, right? If that's not there, that's bad data. You'll spend 6 months training this, and that's not worth it. When you combine that data with the anonymized data points, you want to know whether your visits are actually aligned to it as well. Because if they're not, then it looks like something has gone off, right? And while we could imagine scenarios sitting here, there are cases where you might realize that, oh, there's a mall, but it's split by a highway, right? You don't typically imagine a highway sitting in the middle of a mall that is spread out. And these are only things that you will realize once you try to experiment it as quickly as I can, right? Whether it's a Jupyter notebook or a production grade pipeline, both are different ways to achieve it, either faster or a bit more later. Now, all these choices meant that we had to run for it, right, effectively. So we had some downsides as a result. Effectively, it meant our key thing is we want to test whether the product works, not whether the code works, right? So integration testing effectively happens on UAT. There is no development feedback cycle as much. There is a product feedback life cycle. We had our CI pipelines, but they were mostly responsible for deploying the code, not necessarily for gaining that confidence on whether it's good enough, right? And all the choices around Airflow and Spark worked fairly well for how we were working with it. So then, now this works for sort of well, right? People are able to use it, they're able to run campaigns. What we used to take 2 weeks before now takes a couple of hours. People are able to really run the system in UK, right? So what's the next thing you do, right? You effectively say, hey, maybe let's go to some other markets, right? It's time to grow, and effectively that meant, hey, can we go to the US, right? That's a massive place to go to, and we're going to need some dashboards there because it's a new place, not an established player out there, so I need to be able to sell this as well, right? And people love dashboards, so we should have those as well. Now, what does that really change for us, right? So one, if you've seen US on the map versus UK on the map, it's massive, right? And massive means the data set is also going to multiply. So effectively, we're looking at 10x the data volume, right? Now, 10x the data volume means your device points effectively that you're getting is around 5 billion instead of 3 or whatever that we had before. You're also processing this data daily because if you're now effectively seeing the scale change here, right? The geolocation boundaries are roughly the same, while you could have them go a little bit up and around. Inventory is also up by a 4 to 5 different factor. And now I think you should start noticing some of the numbers there, right? So if you think of visits, it used to take 8 hours to run this. If it's going to take you 8 hours in a single day to run a pipeline and it fails, that's 16 hours that you have lost. You have only that much development capacity to actually run with it, right? Because this is part of your team. So you only get 3 tries at max, after which you are actually now lagging in terms of what days you have processed. So the appetite for bugs is really low in such a country, right? But this is with something that has no tests. So how do you do something like this, right? The other part is cost is also going to start spiraling out of control, right? Because some of these models don't look at just the current day, right? It's not like you're going to identify something purely based on what's coming in. In certain cases, we will look at the last 3 months of data. So as this data accumulates, you're going to start looking at a lot wider window, and all of that in your Spark clusters need to be resized. You need to really look at a lot of different dimensions out there. Now the overall structure looks similar, but the data does not, right? So the data providers in the US are going to be very different. They might give you a completely different schema, so you need to ensure that this is a lot more consistent with what you have. The inventory is roughly similar because we own most of that inventory, right? You have that flowing through your system, so you have a fairly good ground in terms of how it should work. The geolocation boundaries are going to be different because US has different administrative boundaries, right? So that's a very different layout as compared to what we have. What you see out there on the top, which I hope is visible, is a few grayed out cells as well, right? Now, the same question applies true for us out here. How do you ensure that you can go validate that early that this is going to work? So effectively, you want to build the product again, but minimize the risk of this going off, right? Because it's a new data set. You don't know whether that works for you. So effectively, we took an approach of taking out that aspects and saying, hey, we're going to take third-party data sets for our audience, but keep the impressions for it, right? Which impressions is basically, have you seen this frame or not, right? Because if you have an audience and you know what they might have seen, you can actually combine that and say, maybe these are the best billboards for these people to look at. Cool. So, we sort of got certain things right out here, and we didn't wait for this to run. Okay, so most important bit here was, based on the data that we saw in the UK, can we do some napkin math to figure out what will it mean in the US, right? You know the indicative data volumes. Can I visualize what will it mean for my infrastructure considerations? And it's not trivial because, oh, it's 10x, so let me just throw 10x hardware, because some of these jobs combine data sets, and it's a cross product, right? In which case, that data set is going to suddenly multifold, right? And with data skew, right, like New York might be heavily populated versus something like Texas might not. So you're going to have a lot of these variations also come in. So can we account for some of these and maybe take a crude enough estimate to see what it's going to look like? So we got all that right, but not really everything, right? So like I said, we were running this on spot infrastructure, which means our cost was 70% lower. But that also meant that if you are running longer jobs in the US at that time, our spot interruption, which is basically your infrastructure being killed midway, were a lot higher, right? And effectively that meant a lot of pipelines would fail on a day-to-day basis leading to more alert fatigue, right, for the team. The other bit was we sort of had to refine the infrastructure, right? Like we focused on the critical path last time. That meant we made sacrifices on the other. So effectively, we had to make the infrastructure a lot more robust. So things which were partially automated, right? You have a Docker Compose file maybe. Can I make that production grade, run it in a CI pipeline so that it just happens seamlessly? That is one upgrade on top of it. The other part is data, and this is the one that is going to keep you worried either ways, right? Because what you see now is not going to be the same few months later either. So instead of getting hundreds of observations per day, what if you just get 10 observations in a day? Can you determine a visit on that basis? Probably not, right? So how do you account for some of these things like that? So I think bottom line for us out here, it meant that, hey, can we first squeeze the pipelines a little bit? We can't have pipelines that run for 4 hours, right? If it's going to run for 4 hours, the odds of it getting interrupted are also a lot more, right? So you need to make sure that maybe they run in 20 minutes, which means you need to scale your infrastructure, you need to refine your code, and get all that sorted as well. So this was a slightly modified pipeline. The green stage is the extra one that we have. We didn't have that before. Effectively, now running tests in the pipeline made sense because you have UK, which is in production, where if you break something, users are going to complain about it. You want it to work across regions. Now, how do you get to something like that for a code base which is maybe 60, 70K lines of code with very little confidence, right? 4 to 6% test coverage to sort of incrementally build and support a new region. So that's a challenge, right? So we started in different ways, right? And most of you all might have hopefully seen a test pyramid like this. This is a classic one when you start off with something clean, right? You have nothing in place. Why don't I start with having most of the unit tests so that they run fairly fast and a little bit of unit integration test and E2E test so that I have confidence across the system. This isn't going to work for us, right? Because it's now in some sense a legacy code base. We've built something that is a legacy. So can we sort of refine that? So that meant that, hey, can I iterate through this? Effectively, you start off with integration tests because they give you a good enough test bed. Then you start remodeling the underlying DAGs, which we built as code, and then effectively migrate those to unit tests, right? Now, if you add these in the pipeline that we saw out here, effectively you will slowly start getting better, right? And this stage in our pipeline was designed such that you can only take the test coverage higher, not lower, not the same, which is a pain for every developer now to work on it. But every incremental step we are taking, every commit that we are making, it's now getting better for everyone else to sort of use it, right? And that's where it really starts shining. So we went from 6% coverage to around 96% over a span of 2 to 3 years to doing seamless Airflow upgrades, right? Airflow V1 to V2, for those who have worked with it, it's a bit of a jump, right? But after that, everything is like a linear bump for us, which didn't really matter, right, as much. So that really worked out well for us. The other bit now from the parts that we talked about earlier as well, right? What can possibly go wrong in the system that you're building? You could have missing data, which is what we saw in the UK as well. You might have just 1% of the data flowing through, and you can't check this directly because all your pipelines are going to look for input data. Yep, I have the input data. It's going to run through, and your user is going to complain about it 3 months later saying that, hey, I tried to run this audience. Apparently on Tuesdays, they're not going anywhere. What's wrong? So you need to basically go back, correct all that data that you've gotten wrong, and that's a really expensive process, right? You could also have slowly degrading data. So rather than just jumping to 1%, it might go to 90, 85, 80, and that is painful because you will not catch this with static checks. You will not catch this with a really low percentage check. You need to check whether you have anomalies in your system, right? You might also have issues around boundary information being overlapping, right? So US is a different place. In certain cases, your zip codes overlap with each other. So you'll have one zip code living inside another zip code, which practically doesn't make sense to me, but there are reasons why they have this, right? So all of these are other dimensions that start adding to what are the things that you need to take care of. So how do you safeguard against something like this, right? So effectively what we did is we started adding some sort of data quality checks, right? And I'm sure all of you all have heard about data quality in different forms, but they're extremely important in the system which is being used in production, right? And for us, if we have to do this incrementally, it meant that, hey, can we start safeguarding our entry points, right? Because we have now started adding unit tests. We've started making the system more reliable from there. But if I have this safety nets at the entry point, then I can prevent bad data from flowing through, which means that I can now do this a lot more reliably. So effectively, to recap Feudal Ages, right, like what happened there, data quality saved us in a bunch of different ways. And these were learnings that we had purely because we failed at it the first time, right? I mean, every time you realize that here's a problem that is not solved, the first question that goes in our mind is, can we do something about it so that I don't have to look at it again? Because being someone on support on this team meant that you would expect, hey, can I get a vacation after this? Because I feel like I've lost my mind trying to survive the support period, right? So you really want to make sure that the next person who goes through this is feeling a little bit better than what you did. And hopefully 3 months later, when you are looking at it again, it feels like a piece of cake, right? Everything works well. So the napkin math also helped us in a lot of ways. If we had gone with nothing out there, it would have meant a lot of different surprises, which meant that maybe we would have missed the deadlines associated with this one. The incremental adoption of practices was another key thing, right? You can't go from 5% coverage to 100% overnight. You're going to need to do this incrementally. That means you need to have systems which take out the debt for you, right? So for example, we used Vultr to figure out what's the dead code. I don't need to test dead code. Let me take that out of my way. You can add static type checks, which effectively give you confidence in your ID that, hey, is this type really the type that I care about? I don't have the unit test, but this is a really skeleton structure to tell me this method doesn't return what I think it does. And especially with Python, where you don't have like compile time safety, you really need whatever you can get to be able to do this with confidence, right? Because if you don't have tests, this is all you get, all you have, right? So that really helped us go up, and you get a bit of a dopamine hit to fix all of these issues, right? So instead of 2,000 issues, if you bring it down to 500, that's a win for the team, right? And we would celebrate all of these incrementally. Cool. So that's primarily what I wanted to talk about. I'll hand it over to Aman to talk about some of the other bits.
Thank you so much, Anay. Now that we have covered some of the parts in the dark and the feudal ages, where we were surviving the scale, it's like we were making incremental changes, but it was still difficult for us to actually handle the whole scale. What we'll do in the castle age is we'll try to think about how we can shape the scale. If you think about, we've built a product which was surviving, we've built a village, but whoever's guarding the village, they need some kind of support for themselves as well, right? We need to think about building trenches, fortifying the walls, and all those stuff. Along with these things, we also integrate some of the products that are already there in our stakeholders' ecosystem to visualize the data in a better manner. This is the architecture that you've seen in the previous slides. To point the changes that we've introduced, look at the bottom, and in the side you will also see RDS. When I talked about supporting the platform, it was when you look at this view, it's very easier for you to go through and see what's happening here. You can easily see the lineage, but this is not the luxury that we had. This is something that we've built, and as a developer, it is very difficult for you to understand what's happening in the system. If something fails, you need to figure out where do I go next. That's when Marcus kicked in. You wanted to visualize the whole data lineage in a single place so that it would be easier for you to support. The other bit that we integrated is the support dashboard, where we try to bring the whole system in a single place where I could say and see that, okay, US is doing fine, UK is also doing fine. We don't need to worry about anything. And if something fails, okay, this is what's wrong. Just let me go there and fix the thing. I have markers with me. I know if something fails in enriched location data, then I know where I need to go to look for the failures. And if you look on the right, we also integrated with the other products in the ecosystem of the stakeholder. We had the data, right? We were visualizing it using notebooks, Athena. We also had a dashboard at this point, right? We wanted to make it more useful for other products. Our users are using the platform, but can we make it more easier from them? So that's why we've introduced we have exposed the insights on our system to the other products. This is the typical architecture that you'll see. You have some jobs here. The primary thing that we used to run our jobs on was schedules. Every job is working on a schedule. It's like a machine, right? It's literally a machine. You say just consume the data at 12 a.m. for device locations, and then you say consume the data for enrich location and start the job at 2 a.m. This goes down and down, right? But while consuming the device location data, now you've seen a problem. There's something unexpected failing there. You don't know what it is. We'll see what is that unexpected failure there. But now that the device location had failed, we had a schedule in place, right? So you effectively, enriched location data doesn't really care about what's happening there. It will see that I need to consume the data. Now that the data is not there, it will just fail. This will go on and on. Enriched location data has failed. Now visits and impression are failing, and this has impacted the end data. That is the useful bit in our system. That's what user need. Now it's not there. But so what you need to do to solve this? If you think about this is what you need to support actually. It shouldn't be my job as a developer or someone who's doing the support to look at this. Like, this is a short cross section of how many jobs we have, but we have a lot more than this. So it will drive the person on support crazy that they need to clear this. Now device location is passing, and they need to go all the way down to see if everything is passing or not. You need to go and re-trigger every bit, but that's not how it should be. So what was the unexpected failure there, right? This is another DAG. This is how a typical cross-section of a job, when I say I'm processing the enriched data, this is how it looks like. We start processing the data, we look for input, and we also ensure that the output is missing. And then we start processing the data. We start creating the clusters, we add the steps to process the job, and then we see if it is processing or not. And based on the results, if it is failed, we'll have to alert someone, right? Like, okay, go and look at this. This has failed now. And if it has passed, what we do is we do the data quality checks. This is what Anay was talking about when he meant we can't let the garbage data get in our system, and we need to stop it right there. This is like location data has produced its input, right? Now it has an output, it needs to get it to enriched data location. But to ensure that it gets the correct data, we have a DQ check right there. If it is correct, we'll mark it a success job, otherwise we'll fail it. So this is the cross-section that you're seeing. You might also think about, now we'll start seeing what are the issues here. There are multiple places where things can go wrong. We are looking for input's not there, fail. Again, we're ensuring that the output is missing. And in that case, there could be multiple scenarios, right? This might not be the first time this job is running. It might have already ran and it failed. It wrote some things down and it failed. The cause is spot interruptions. We are running on spot. We don't know when it will go away. There could be another issues where it actually wrote the output down completely, but then the spot interruption happened, right? In that case, it is a good data that you can use it. Now, the input is present. You ensure the output is missing. Now let's create the cluster and let's create the cluster and wait for the next steps to begin. Now you're creating cluster. You send a request to AWS, give me 50 nodes that are running on spot. Cool. Now there's a very high interruption rate in US, UK, wherever you're running your job, and AWS can't fulfill your request. It has failed now. Then, right, that could happen as well. Then as someone who is on support, what you need to do is wait for some time and retry based on the criticality of job, right? Anay, while talking about the architecture, Anay talked about a job which used to take 8 hours. In that case, you can't wait. You just need to put it on demand and get it over with, because if you lag behind, you're just catching up on your previous days. Now that you're adding steps, right, you will also try and see if the job is running correctly or not. If the command that you're running Spark submit, if it is correctly running or not. There could be multiple failures as well. Even now, right, your job is susceptible to interruptions. It can easily fail, right? Then what you need to do is retry again. It's the run book for multiple failures that you could see. You have a guideline that you need to follow. You move on to, there could be multiple issues with the job while it is running. Suddenly, like Anay mentioned, you're trusting your data provider to give you a correct data. Suddenly, there's a season of Christmas, right? Wherever you're receiving for London, you're receiving your data. Now it has increased multifold. The job is not tuned for that, right? The job is supposed to run on X amount of data with Y number of nodes. There you need to increase the resources. Based on that, you need to fine tune the job as well and then decide. If these are neither of these reasons are applicable, then you need to get into an EDA mode. You need to look at the data, what is happening, is something missing, is my schema misaligned, did something get through the DQ checks, do I need to tune something else? This is something that you need to do when you are on support, all of these things. Now, so you've been through this pain of supporting all of these things. Now you can at least need to think about making the pain for whoever's next on support a bit easier. What you do is you add intelligence in the critical things that are susceptible to failures. You have input present task, you have output missing task, you have create cluster and add steps. Can we add intelligence, right, to reduce the repetitive tasks that are there? Here's a wait and retry, there's a wait and retry, here's also a wait and retry, there's a retry again. Can we make these repetitive tasks automated so that whoever's on support, they don't need to worry about these failures. They can actually focus and do their analysis peacefully. Create cluster is something that we have added intelligence to. Whenever you are facing a spot interruption and the rate is very high, what you need to do is wait for some time, wait till the rate gets down, and then retry again. Same with the input present. It's not something that is waiting. So when I say input present, we look for a particular file, and if it is there, we start consuming the data, right? If this is something where we can automate, we'll say that just keep polling and looking for the file, and then if it is present, then start it. Otherwise, fail. There's a timeout for this, but this is still a much better solution than what we had before. Looking at what the things that we did here is we talked about DQ checks. As someone who was supporting the platform, it was difficult for them to go through all of these things. If we look at the feudal ages, we made some incremental changes that helped them to make their lives easier. We also ensured in this age, we also ensured that we will stop the bad data getting into the downstream and have a feedback there if something goes wrong. It's very easier for us to know where the system is failing and then fix it right then and there. At this time in the project, right, what was happening is developers were supporting the platform. Now we just can't be doing support, right? It's not what the stakeholders are paying us for. We need to move this and find a better solution for doing support. So this is where we change the the this is where we change the designations of us from being a primary support person to data ops for the stakeholders, and they will be doing the support from now on. So we'll see, as a developer, it was still the whole flow that we have right now. It was difficult for us, but when we are a developer, it's still easier for us to understand how things are going. When you're transferring your responsibilities as from developer to a support person, it is difficult for them. So we'll also talk about what changes we did in the next age. Even by this time, we had added a couple of more jobs in the system. And the job runtime was something that was very troubling to us. Some jobs used to take a lot of time, and that was not something we were comfortable with. This is when we decide and keep a guideline that we need to reduce the job runtime as much as possible. We need to optimize the job. We need to change the logic. We need to think in a way where it will not take a lot of time. Now that we've made and simplified the data operations a bit, right, it is time to take it further. Now it's not you who are supporting the platform, it's the data ops team who don't know about the concept on how the platform is built, who don't understand Spark, who don't understand Airflow. We need to help them with understanding it better or making their lives easier. And by this time, we were already operating in UK and US. This was the time for us to venture into a new region again. That was Canada. How many of you, while looking at the system, can tell me what does this represent? Anyone?
Region.
No. Anyone else?
Error in the DAGs.
Yeah. So this is, we've seen the architecture in the previous ages, right? It was just about the job. It was just the name. Now if you look at this view, this is actually a reference to the actual job. How is the location data doing? It is very easier when you look at this in this way, but this is something that the data ops need to carry in their mind. Location data, enriched location is after location data. After that, I need to look at impression. If insight's failing, oh, okay, I need to think through all of this. And this is, we are thinking in a single dimension. We are just thinking of today. This is n number of days, last week, last month, what's happening there. It's difficult to visualize this. And that's why we created a dashboard which will exactly do as you see here. For anyone who's supporting the platform, it's very easier for them to go through this view when you have this in your Airflow. This is what a DAG of DAG looks like. We had every job which was another DAG, and we created a DAG out of it. We've made some more changes in the architecture part. You can see it's not, the job portion has not evolved as much, but if you look at the bottom, we had markers, which helped us with the lineage. At least we thought it would help us, but it didn't. At this point in time in our project, it was a waste, and we don't really needed it. So we killed it, and we created the new support dashboard that we just saw in the previous slide. What this gave you, looking at the older version, right, it was just giving you a status of a single job. If location data job failed or not. That's the only thing that you get out of it. You don't know what's the status of that job past 3 days. You don't know about it. But this is a DAG. Those who have worked on Airflow, you know about the grid view. You can actually go back and see how the system is doing in terms of the status. The job specification that we looked and talked about the potential areas where things could go wrong. This is how it looks like now. You might notice there are a couple of things that we've reduced, and there are also some intelligence that we've added in terms of reducing the blast area for those jobs. We had these intelligence built in the system in the previous age. What we did now is we've seen scenarios where spot was a problem for us, and by this time we are in 3 regions. Like, just imagine the scale of that. You have almost 40 DAGs running in each region, and there are 3 of those regions. It will be crazy if the spot interruption rate goes high for each region, and there's a single person or a group of people, maybe assume let's 2 people who are handling this thing. It will be crazy for them to just go and retry every time this fails. This is a problem, and we solved it by building the intelligence where you could say if we have a categorization of job where we know this is a critical job, and if this fails because of spot, just don't wait, create an on-demand cluster, retry, and get over with it. And we have a categorization of jobs where we can say, okay, this is something where we can tolerate the failure. Let's give it one more try. Let's try with spot, right? And this is something that will actually help someone who's supporting the platform. We've gone into Canada now. We had been to 2 other regions. It was the first time that we did. It was a bit difficult for us, and I talked about the tight timeline that we had. We set up 5 models, all of those stuff. We did the same thing in US again, and now we had to do it again. So this is again a repetitive thing. This is a trend. You don't know when the business will go into a new region, and you need to prepare for that. And this was a time where we made a conscious call that we will wait, will think, and we'll see what things we can actually change, so that the next time we go into maybe India, it's going to be a lot easier for us. Whenever you think about 3 regions, right? Let's take an example of a code. When someone who's just working on the code, you might think of something like, if US do this, if UK do this, and if Canada do this. At this point, we had to stop doing that. We need to think about something that is very configurable and make those changes. So this time, we took our time, made those changes, refined the abstraction, and also made some modular changes in the infrastructure in Terraform that we had. We made some changes that will really help the next time we go into the new region. Spark upgrades. So how many of you have worked on PySpark with pandas, with scikit-learn, with NumPy? And those of you know, even without Spark, right, Python is a real pain when you need to balance the versions of pandas, scikit, and NumPy, right? Now that's why it was a very difficult thing for us to decide. And it's not just PySpark. We also have Scala. JVM is something comparatively easy to Python, but you still have a problem there. And when you think about balancing the version, it's not just one job. We have almost 40 jobs that are written in that way, and 5 to 6 of them are models. So they'll have a lot of packages in them. How do we actually do this? How do you make upgrades much, much faster? This is the cross-section of job. And when you look at this, the setup that we have made is we'll have a Spark 2 job and a Spark 3 job. Whenever you're trying to upgrade a job, you're experimenting with it. You just go, enable the toggle in Airflow that I need to experiment with location data. What it will do, it will start the 2 runs. It will take 2 different artifacts from different places, and it will run a parallel visualization, like you can see, right? It will run it like that, and in the end, we had a job. What it did is it compared the diff and wrote it down, and now your job, after upgrading the job, is to look at the diff. That's what you need to do. So this is much simpler way. If you are doing this manually, you are running the job, you'll have a diff, you look at the diff, like people who worked on Spark, you know about except all, how performant it is, right? And the job is doing the same thing, but it's not you. You have the time, you can do something else. Maybe you want to upgrade a new job, right? You will easily able to do that. So let's talk about the things that we did in the Imperial Age. Now that we have changed the responsibilities from us supporting the platform to the data ops team, we had to make certain changes. We changed the data, the job specification. We changed the support dashboard. We created a new one that helped us support the platform very easily. And we went into Canada. We also talked about some of the changes that we did, the modular changes, and making them in a way where whenever you create a new region or venture into a new region, you don't need to make a lot of code changes. It's only the configuration that you're playing with. And yes, the last bit is the optimizing Spark upgrades. We had a mechanism where we automated the comparison of the data diff. You might think that you just upgraded a version. Does it really change your data? So people who change Java versions, you might know about the float precision. We are operating with latitude and longitude here. You don't know what will change, so it's very difficult to actually understand what might go wrong, and this is something that helped us move at a much faster rate. This is all that we had to talk about the bit. I'll hand it over to Anay now to summarize the talk. Thank you.
Cool. So you might be wondering, this all sounds like a great story, right? Like what am I going to take out of this? So I think if you're starting now, or if you're wondering how can I apply this, right? For us, at least for me, I think I would sort of keep some of these things in my mind always, right? One, if you're doing even really small incremental improvements, right? Whether it's adding tests, whether it's making something slightly 1% better, I think the benefits that you get compound a lot more over time, right? So while initially the mountain might look really big, but if you start chipping away slowly, I think it makes for a really smooth ride. The other bit is eliminate waste. I think Aman sort of talked about it, right? You might have made choices in your system based on what you thought you might get as value, right? Marquez, for example, is a great system for some uses, not as much for us, right? We want a system that really simplifies our tech ops life, and that we achieved by doing something else instead of this. Ruthless prioritization, I think this has been a theme for us at the start as well as on an ongoing basis. You want to focus your team's capacity on what is really relevant for you right now. Data quality, I think I go through horrors if this is missing, right? I mean, this needs to be a really fundamental tenet. You need to make this better with every passing failure that is unanticipated. If you see something that doesn't make sense, you need to make sure that it works better, because otherwise you're going to struggle with alert fatigue, or you're going to have surprises downstream. So pick that battle. This, I think, can't be say, is around plumbing, right? So data engineering at a very crude level sounds like plumbing. You're taking some data from A, dumping it at B. And I think engineering is where that rigor really lives. I think it's important that as data engineers, we think about the data, understand what's wrong. And even just knowing what's wrong is good enough to start a conversation. And that basically means that you can start accounting for it in different ways, which is a data quality check or having tests or whatever else. But if you don't realize it, it's effectively garbage in and garbage out. Lastly, I think auto-healing is a key thing. If you're losing a part of your team's capacity, just doing things that are repeated and wasted, right? That's capacity lost, effectively. You're not getting it back the next week when you'll have to do it again. So you need to really think about how can I have auto-healing in my system so that I don't really have to go through the same pain again. Right? That's primarily what we had. If you all have questions, we're up for it. We're out here at lunch as well. So either of those. We have time for questions? Perfect. Okay.
already been. Just give us a sec.
Sorry, Wilson.
Yeah, hi, Anay. I have one question on the data privacy itself. So a lot of this data of visits and end user data which is flowing through the system, how are you maintaining the security of that data? I know the data quality you talked about,
Correct.
which is at source, the data is not manipulated and the sampling is good enough and it's real data. But let's say it's real data which is coming to the system, but how are you making sure it is safe in the system?
Yeah,
And
so-
it is not getting spoofed and there's no leak of data when it goes through all these pipelines.
So I think that's a great question, by the way. And I think that's a part that typically gets ignored, right? So the question is basically, how do you maintain data privacy in a system like this, where you might have access to sensitive information? I think it comes down to a few basic things, right? One, if the data is not required for you, don't keep it at that granularity. Right? Do you really need to know exactly where they went, or is a high-level abstraction good enough for you? Right? Because then accordingly you can refine your data and discard it so that you don't have anything that can go wrong if you have a leak. Right? So that's like one step where you have things that look sensitive and they look wrong. Don't keep it with you if you don't need it. Right? Now you can also change the granularity at which you store it. Simple things like, if I want to track a visit, do I want an individual to be mapped to it, or do I want to know that this is a cluster of people who are out there? Right? The other bits are more around access control, right? You want to have the system audited, one, in terms of what sort of information is getting traced in third-party systems. So you could have things like CloudTrail, logging, all of those. You could have access control in place, which prevents unauthorized access as well. As an engineering team as well, what sort of practices do you use, right? I mean, whether it's multi-factor authentication, whether it is, you need to think through attack vectors effectively. Think about what is it that I might lose from this data set that I've created, right? And how do I safeguard it? So those are the sort of choices we would make to ensure that this doesn't go out. Hope that answers your question.
Yes, thank you.
Just closer. Anyways.
So for the data quality checks, so are you using any kind of tool there, or how it is, and what kind of data quality checks you will doing?
So the question basically is, what tool are you using, and what's the kind of data quality checks you want to have, right? So we started off with using Amazon DQ, which is works at a Spark scale, right? You don't want frameworks which only work in pandas, for example. Our data volumes are far too massive. It's at a petabyte scale. You want to be able to run things that can run on a cluster to check what happens. It's not necessarily a great framework, by the way, on its own, because it's a tool. It's a nice library that integrates well with Spark, gives you a nice DSL on top of it, but it just gives you the foundational blocks. We had to build layers on top of it, which basically meant that if I want to visualize the trend of a metric over time, it's not something that it supports. It doesn't have a data store. So you would want to start pushing this metric somewhere where I can look at on a time series, hey, do I have enough data flowing through? When is this trend gotten worse, right? Now the trend is really important because you want to see, okay, last 4 weeks looks like the data was off. Maybe that is when I need to start talking to the data provider. You also want alerting capabilities in there. So if things don't work, it's not just the process exit with a status code of whatever, right? I want to notify the team. I want to fail my DAG. I want to do a bunch of different things with it. So those are also other things that we would start capturing. In terms of the kinds of data quality checks, I think we've done few different tiers, which we briefly talked about. One is, hey, is my schema first matching the data set that I expect, right? Very fundamental check. The second might be more around, do I have the data, which Aman clearly touched upon, right? Then, is it good enough as a value, right? As a trend line, for example. Over the last 5 days, 5 days or 5 weeks or whatever, right? Is my data constantly going down? Because you're going to have variations. There's no control on this third-party data set. But what is your tolerance level for it, right? Maybe you are okay with it going down by 5% over a span of 5 weeks, right? If not, you want to sort of fail that pipeline as well. So we have started adding layers on top of it, which are anomaly-based pipelines, where we would try to look for some of these patterns and then accordingly fail it as well.
Hi, Anay. So where open source and compatibility with AWS ecosystem were strong indicators of, did these actually drive choices? going with airflow and all.
Right. So, sorry, let me try to understand that question a bit. So, your question is effectively like choices and airflow and Spark.
So, two different questions right here again. So, one is, did you had to use an open source tool for doing this? And second is, did you had to ensure that anything that you use is compatible with the AWS ecosystem?
So, I think, so the question basically is, was there like a mandate to use open source,
like
right? And effectively, how did that work out for you in the AWS ecosystem? Right. So I think personally, we've few elements, right? One, what we've seen with proprietary systems is that they generally tend to be limited in some ways, right? And we don't want to limit our architecture in ways that we can't control. You want a mechanism where you can hook in at different places to sort of do that. For example, if you look at Airflow, there's a massive community out there. A lot of people in our companies are also active contributors to it, right? So you want to pick tools which make sense for your problem statement. And in this case, it was a perfect fit because it gave us the visibility, a lot of the monitoring, a lot of the logging, right? And fit fairly well in what was needed. Now, you could do this very well with something like maybe something like step functions and using AWS, but you're not going to get some of the other supporting things that we need. And that also limits you in terms of portability, right? Now, we started with this at a time when AWS didn't have a hosted version or a managed version of Airflow, right? While that does exist as a choice as well, we've still gone with our own because effectively it is a lot more open, one, and I think the cost is also a lot more managed with the open system.
So you hosted Airflow on your own?
Yeah. We've also pushed that boundary, right? So when we started with EC2 instances. You push that boundary, let's move to ECS. You start pushing that one notch up with every passing region, and that goes back to us making it better.
I think one more thing is that the principle that the product was built on was to do own things, and Anay actually touched upon that it limits you in certain ways. So if taking an example of the support dashboard, to some extent it might seem like an anti-pattern. You have monitoring for your DAGs built inside of Airflow. You could have used other tools for observability, but for our use case and the prioritization that we did, it was the best choice that we could make.
Yeah, we've had some very interesting debates on, hey, this should be a solved problem
by now.
5 years in, why do we need to build this again, right? And I think what came out was actually a lot more usable for all our users. Cool. So if you have more questions,
Anay, I have a question. So why AWS only? Why not Azure or GCP?
So I don't think there's a particular preference there, right? I mean, you could very well run it with whatever you want to, right? I think the question is, does it fit within what you're trying to build, right? And how well? If you have the flexibility, so I wouldn't sell myself to AWS that this is the best, I should always use it. In my mind, AWS also gives you the 60% of a product and leaves the 40% for you to build, right? Generally. The APIs exist, you build what you want to do with it, right? It will not be all the way where you have a fancier dashboard in there which lets you do things. GCP might push that boundary and give you the dashboard. Now, do you care about that dashboard? Do I want something else there instead? Right? So some of those trade-offs, I think, will matter.
Hello? Okay.
Here we are talking about the data engineering.
Yeah.
So if you look at from the perspective of GCP and the BigQuery capability, they are well versed,
right,
rather than AWS or Azure.
Yeah.
So why, when you are talking about data engineering, why not GCP?
See, I think so there are a lot of capabilities that we need from the platform, which I don't think will get addressed over BigQuery, for example. I know one way to visualize this is, hey, I want to have a grand data warehouse in some sense, right? Which can give me different sort of insights that I want to take out of it.
And cost-wise as well, GCP
Absolutely. It's a market leader in that sense in terms of cost.
And the hardware as well, the data center-wise, okay? And the compute power, the energy that they used is very optimized rather than AWS. So sustainability point of view is, if it is a big data, GCP is the right. Anywhere in the globe, you just take it. They are using a GCP.
Right. So, see, I see it's a choice. I think it depends on what capabilities you are looking for, right? If you look at BigQuery and you want to externalize some of those data sets, if you want to run machine learning models on it, I know it also supports some of those capabilities even within the querying mechanism itself, right? And that's great, but that also binds you a little bit to that way of working. So I would love to have this conversation with you further, but maybe we could do a one-on-one after that. Correct. So we don't run all of this. So sorry, I'll just repeat what he said. If you're looking at a petabyte scale, you would want to focus on sustainability as well, right? And that is absolutely true. For us, it's about also keeping the cost low, right? Cost is one dimension of it. Sustainability is an absolutely different dimension. Yeah, it's the need, absolutely. So I will drive this, sorry, just to close that point, I think we don't necessarily run this in a hot cluster in some sense. For us, auditability matters, but that's on S3. We are not really running compute on top of it at that point. The compute is short-lived. We don't keep clusters idle either. It's only for that specific use case where you start the cluster and you kill the cluster and you're done. And these are also optimized for which clusters you choose. So we ensure that we pick the ones. So if it's Graviton or if you want to push the boundaries there, you pick the most relevant ones.